We are back with open sourcing StarkOS from WeWatchWall. I must excuse myself. I had to take a little break to do some of the last steps in the alpha of our orchestrator service. So I'll get to that, what happened there in a few minutes. But I just wanted to say that today is just going to be a short recap and update on progress here on StarkOS. So, what's the idea? Well, if you know Docker or Kubernetes, you know that you can have that orchestrator on Linux usually or Windows that essentially allows you to create light containers or virtual machines that don't take as much space as a full virtual machine and also allow you to orchestrate or deploy software across those machines. And what I did was I used Kubernetes or K3S in my case over a machine in my Hyper-V um, virtual environment, and I deployed CouchDB to it. Now I could have done that on my Raspberry Pi as well, but the problem is that Docker or Kubernetes also requires a local area network connection or a VPN, and it requires you to run your own server environment, which is not good if you want to have a deployment that also includes a client, such as my browser, which isn't as easy to manage because it's not in a trusted environment. At least that's what the server thinks. But the point is that browsers are now sandbox, so they're actually a lot easier to think about as secure than when I think about running code that's orchestrated. I would easily rather run it in a browser than run it on a server. So I decided that I'm going to use Node.js and TypeScript, and I would create my own orchestrator that will work across these environments. So it'll work in the back end. I call that core. It'll work on the Raspberry Pi, like across the internet. I call that edge. And it'll work on the browser. And the whole work is going to be based on CouchDB. Why? Because CouchDB is very geared towards HTTP, JSON, things that JavaScript and TypeScript can work with. Okay, so what I did was I launched 3 nodes. If you can look at this URL, you can see that you can see my nodes here, and they're replicated between each other. So they improve reading speed and they improve writing speed by replicating between multiple servers of this CouchDB instance. Now, in order to make everything work, I basically had to go to each node and using HTTP request. So that was one, and then there's 3 nodes. There's also this one, and I I had to launch HTTP request to change this couch per user setting that enables and deletes database per user. So every database you see here has a user here in the user database. And That's a fairly cool feature, but my issue is I could be DDoSed, but because the users management, like I could add users, infinite users from a public domain, because in order to have both this replication, this node cluster, and these settings, I need to keep my adding of users public, which I don't want. And actually, I kind of, what's the word? I encapsulated that through my server. So now I have, instead of those public routes, which I will leave for now, uh, until the beta, which kind of starts today, the development of the beta from the alpha. So starting today, we're going into the beta, but for now, I still have those public routes, but I encapsulate those with server routes, which allows me to add users to the databases, and it allows me to add nodes, which also use the same users and databases, but they contain different data and they're marked differently. And they're also replicated um, to the user. So the idea is for this user to then use this replicated data to log into. So I've also given this user permission to log into their NodeDB. So you see, admin has access to their node. So they can log into their node and manage that based on information that they can watch and read from their user DB. So things are fairly streamlined now. The last thing that I did, okay, so let's start from the top. First of all, there's a user config, and it keeps track of what nodes it has. And then as the node gets added, it gets replicated and it has its user given its permissions to access that database for the node, which is the resources, the computing resources. Excuse me. And what I'm then able to do is I can say, oh well, I can say add package config. I guess I might have to add another more fields here for package configs, and later on for volume configs, um, volume config, service config, and maybe friends or something. I already have some, but anyway, uh, for now it just has nodes, which then user, and then the node, it has pod config. So what the pod config does is it deploys these package configs to a pod. So you can see the reason why there's two here and only one was deployed is because this is admin, so it has bootstrap configs for both the edge and the core. So the edge one didn't get deployed because the only node here is a core. But if I can use an HTTP request to add a edge user and or another user in an edge node, and that would deploy a pod config for the edge. So the part that I hid from last week that I've been working on is essentially running packages from here. So these get bootstrapped automatically. And what I didn't show you is the fact that I watched this entity, the pod config, and if something changes, like the attachment revision or the status to stop. So if something says stop or the number of pods here, so the way I'm going to do this is the package. The package will have a number of pods, of max pods, and if that gets constricted, then this pod config might just go to 0. So I stop all my running pods. Or if it gets scaled up, then I run extra pods of the same config. So of the same deployed package that is installed here in packages run. So you can see it installed because these two directories exist right now. And right now I just have to finish that deployer or that reactor to react to new pod configs. So what it will do is it will watch these IDs, and then if it's a new ID, it will create a new object in memory, and it'll pull down the specified package from the database, not from this. So you can see here this attachment. It downloads this attachment, it installs it, and then it runs the number of pods that it has specified. And you might see some of this code in passing or as I'm working around some of the other issues. But I won't explain it because I noticed that nobody's following or nobody's really engaging yet. So there's no reason for me to divulge everything yet. Anyway, they will open source this at some point. It's just right now I don't have enough reason to. And what's the next steps? Well, as I said, now that my pods are reacted to, so I can deploy software already, I need to go back and kind of fill in some of the things like deleting pods is still not working because I'll have to create a different process or thread. I haven't decided. It's kind of like I could even set it as a setting almost. Um, I think that's what I'll do. I'll have to do like the sandboxing, so I'll have to sandbox either like no sandbox, so everything's just accessible, or you could have like that would be like an admin setting, or like the user has to specify something extra to get that to run, or they'll be asked, "Are you sure you want to deploy an admin a no sandbox software?" And then there will be like a full sandbox where only the necessary requirements will be deployed for that package and no process or limited process facilities, so that like things like settings won't be available, like the user might not be available, like the database user, I mean, um, things like that. And then I also need to worry about volumes, shared volumes, like public volumes, public services, public nodes, things like of that nature, where where people, like overall, like the users will be able to deploy things between themselves. And then that'll be most of the beta. It'll probably capitulate or like capstone with measuring how much space, so monetizing it, measuring how much space and computer time your script is running for, and then charging other people for that. So the idea is I'll be able to rent out my computer and have, validated, verified other users be able to use my PC as a resource in their own cluster. And that's really cool because it'll be encrypted, most of it, so there's not, I'm not going to have to worry about, and sandbox, so I'm not going to have to be worried about um, issues of getting hacked or whatnot. And also, I can get paid for my computer time. And last but not least, I've actually been working on I think it's groundbreaking AI, where backpropagation will be kind of replaced by more traditional software. So backpropagation looks very distributed, but without a lot of reason. So I found some good counterexamples to that, um, which suggests that instead of using GPUs, it'll be a lot, like the models will be a lot easier to think about. At least in the beginning, it'll be a lot more streamlined to model, to fully model, like AI that just uses as many CPUs as it needs. And that, I think, will be a lot. That'll be able to streamline into GPU, but I think a lot of the connection is distributed AI algorithms that we have today haven't been modeled properly anyway. So it could start out on the CPU and then migrate to the GPU and TPUs, or tensor processing units, later on when the models are in the compilation. That's the thing. It's like if I can model those well and I can create compilers for those models, then it'll be a lot easier to program and work with, but also they'll run as fast, if not faster, than current day AI. And I also have, that'll be like coming out of the beta, that'll be kind of one of the first things. And also security. I'm thinking about quantum like security using domain driven design, or event sourcing, to launch honeypots and kind of observe any unsanctioned changes to code, or even observations to results of these pods, and then kind of either run them down the wrong rabbit hole, or just self destruct the whole service that they observe, so that the attacker can't go on observing once I notice these intrusive observations. So that's kind of quantum like. if you observe it, it changes its behavior. And yeah, that's kind of the whole project. It's very large in scope because this has arisen out of a lot of friction with companies that think they can take shortcuts and just like sit, have be the monkey on your shoulder. And as the coder, I wasn't allowed to receive my engineer's license, my software engineer's license, from people who got theirs and then proceeded on to not do any testing and pretend like automated testing didn't exist and kind of give people ridiculous deadlines and tell them go on call because the company needs you, and kind of like that sort of unfair, un unmanageable spaghetti bowl of issues that we have today. And I look at all those issues a lot in my free time, and to my own health and my own kind of life suffered a lot because I always wanted to do the right thing, and it was never in the benefit of the conservative manager who just wanted to get something out that looked pretty. And yeah, that's me Friday. Signing off. I hope you learned something. That was. I'll do another recap in at the beginning of March. I'll do this monthly or something, so I can have a good excuse not not code all day every time I'm scheduled. Anyway, this is Friday signing off. Hope you to see you next time, and give us a follow. Um, that will make me happier and less prone to skipping days, and more happy to open source more stuff.